As you can see, along these big yellow arrows, water flows through the AMS. Water enters the AMS through this opening right here. As you can tell, there is a small filter over here to filter out unnecessary substances such as seaweed and other objects that can damage the AMS. So the main body of the AMS will be covered with an egg-shaped covering to protect the insects. Along the AMS, as you can probably see, are little papers which represent probes from sensors. Because drill probes were a bit out of our budget. But these probes do stand for sensors, and they are at the actual location where the probes would be. The probes would enter the AMS. They're shaped kind of like a pencil, and they would be, their head would be right inside and their body would be sticking out with the wires connecting to the electronics part, which is right here. We actually have an Arduino right here, which works, it's fully functional, and a GPS location system over here. We have tested it and it is accurate and precise. And we also have an air temperature sensor, which we have also tested more as a proof of concept than anything else. But it does work and it's also accurate and precise. So in the Vrio Aqua Monitoring System, this data would be sent through a radio frequency transmitter to the boat, which would then send the data on to network. And currently on the AMS we do not have this RF transmission system, simply because it was a bit out of our budget. So as water enters, right through here once again, there is a turbine right over here, which you can see over here, and the water spins the turbine and generates electricity for the system. Currently we are in the process of redesigning the turbine, so it would look a bit more like a jet turbine and be more efficient. So it would reach its maximum efficiency. However, with this turbine, we have calculated using the charging simulation motor, which is right here, that it can produce enough electricity at 23 knots to power the AMS. And if the boat is traveling at more than that speed, then it will charge these batteries right here. And you could have more batteries or less batteries. You can have as many batteries as you want. This amount of batteries is enough for the AMS to function for approximately 24 hours. In the future, we may also add water level sensors throughout the AMS, which are represented by these red arrows and these little black dots right here, to check so that if water leaks through, these would alert the captain of the ship or someone close to the AMS who has the power to fix it. Also, the electronics compartment would probably be separated and also in a sealed off container, so if the AMS does leak, the water does not get to the electronics compartment and the electronics compartment remains safe. So once again, I think this is an efficient system. Thank you.